So, topic number 7. So I have here a few things that we'll just read and fill in the blanks, and then we'll do the examples together. So we often encounter systems of equations in which the context is not lines and planes. Economists often have to work with systems of dozens of equations involving dozens of unknowns. So it doesn't have to be up to just 3 equations, 3 unknowns, because we live in 3-dimensional space. So we think, up to 3 dimensions, this is it. But you can actually have mathematically or theoretically multi-dimensional in terms of number of variables that you're working with or number of unknowns. So relying on a geometric interpretation would not be very useful because we cannot imagine a space that's 4 dimensions, 5 dimensions, and so on. And so we're going to talk about what is a matrix. So a matrix is simply a numerical data that's arranged in a rectangular array. So it's going to be, columns and rows. The method of solving a linear system amounts to combining linear combinations of these equations in certain ways. I'll show you how. And since several similar steps are involved, this method is ideally suited for technology. And that's why I'm going to show you how to use a calculator for that, because it's a bit tedious to do it by hand, but I'll still show you so that you understand how calculators are programmed. What are they doing in the background? Because maybe some of you are going to go programming as well. That's math is used in computer programming. So there's a few bullets over here. A system of linear equations can be represented by a matrix, and to obtain an equivalent system, so basically you're going to be doing systems of equations, but we're not going to be writing them as equations. We'll write them as matrices. And I think maybe the best way to do this is start with an example a little bit and then backtrack to fill in those blanks. So I have here an example here with 2 equations, 2 unknowns to start simply. And then I have here the same version J that I had before. So we've already done this solution together yesterday. I'm just going to demonstrate this one with a matrix calculation so that you can see the differences. So let me start off with the simpler one that's just 2 by 2. So what you would do is you would organize your matrix in such a way only the coefficients written down. So the coefficients on the x here is 1, here's 1, here's 1, here's -1, and then we have 8 and 13. So that's all you would record. You'd have 1, 1, and after the line you'll have an 8. Some teachers don't even record that line. They just think that the last one is after the equals. I like to just separate out where the equals was with an extra line. And then we have 1 and -1 and then 13. Okay, so instead of working with variables every time, you have basically less writing because you're concentrating only on the numbers. Next. I guess I have to go back to talking about what do we do with these equations. So as you saw when we worked with equations, we could start adding or subtracting to eliminate things. So one of the things that we could do is to also do certain operations that will be equivalent to adding, or sometimes you would take an equation and multiply it by a certain number, let's say 2 or something like that, and that's still an equivalent equation. So we're going to summarize what it is to do matrices that is equivalent to what we do with lines. Okay, so let me just put those in as the bullets over here. So what are we allowed to do? We can swap any 2 rows. It's basically like saying when we have an equation and you have this equation number 1 and then equation number 2, we can rewrite it so that 2 is on top and 1 is on the bottom. So you're not allowed to swap columns, because with columns represent that the first one is x, the second one is your y. If you had 3 by third one would be the z's. So you want to be consistent that way and not swap columns. So you can swap rows. Second thing that you can do is you can multiply a row by a non-zero number. any non-zero number. And it's still going to be equivalent to what it was before. Just like I said with equations, we can multiply the full equation by a number like 2, and it's still equivalent equation to what it was before. Somebody just came in, a little bit late, but better late than never. Let me just adjust attendance for the office. Okay. And last thing that we can do with rows, these you can add or subtract, two rows. Okay, and that's going to be equivalent to what we did, we talked about here, that when we are trying to eliminate something, we add or subtract to eliminate x's or y's. All right, so I'll resolve that now. And let's continue reading a little bit. What are we supposed to do with this? We're supposed to, I think I should read this part next. The systems of three equations that has x, y, and z represents three planes in 3D space, R3. It can be represented by a matrix having the form that is written this way. Hang on a second. All right, so the next blank. So what is this matrix called? So usually I'd like you to think that this one right here would be coefficients of the x. These right here will be coefficients on the y. These right here would be coefficients on the z. And after the separation, this is the numbers that are after the equals, Okay, so this matrix is called the augmented matrix. And each of these stars represents some sort of number and no variables. When we solve a system using matrices, we attempt to use these three things that I wrote down, these elementary row operations. So I'll write that down, elementary. To obtain a matrix that has a particular format. So this part in front of the separation is going to have ones on a diagonal and then just zeros everywhere else. This particular matrix is called identity, the identity with solution. So this is the identity and this is the solution. Okay, the method of performing this, there's a specific name for it because it's two individuals that came up with this, so they get the credit. Gauss is one of the person, and the second one is Jordan. So this is called the Gauss-Jordan elimination method. Okay. And the matrix that results is the reduced matrix. And sometimes you might hear or see these particular words, or even in the calculator, they call it RR. Hang on a second, I forget. RREF. RREF is what it's called. RREF. Okay, so the calculator uses this. So what does that stand for? It's reduced row echelon form. I'm not going to test you on this, but in case you're wondering what is this RREF stands for, I'm letting you know. Okay, so what is this Gauss-Jordan elimination? What exactly is the process of doing so? I have here already words written down. No, I'll come back to talk about this one. This is like inconsistent systems. I'll do that at the end because that's it gets more complicated. Okay, so the process. What you want to do is you want to start with the first column. Once you deal with the first column, then you move on to the second. But within the first column, or whatever column you're on, your goal is to get the one entry first. So if you're looking at this right here, so if you're working with the first column here and you have different numbers that may not be ones and zeros yet, Your goal is to get the 1 first. So in the first column, the 1 should be on the top, as you can see over here. So your goal is to get that 1. Once you get that 1, your goal is to get the ones below it to become zeros. Then and only then you move on to the second column. And then in that column, this time you're going to be working to get that middle one to be as 1 first. And then you'll work on to get the above and below to be zeros. And then you move on to the next column. And in the next column, you're going to be working to get the 1 first and then the zeros above it. Okay, so that's the process. So how do we get the 1? I'll show you. Getting the ones by divisions, and we'll get the zeros by doing the subtractions as needed. Okay, so I'm going to demonstrate it with this first one. That's really simple. First of all, because we already have all the ones in here. Maybe I should change the question. That's okay. My second question has different numbers there, not ones. So you'll see what I mean. Okay. So we already have a 1 in this position, but we don't have the 0 here. So your goal is to get that to become a 0. So you need to also specify what you're doing. So when you're looking back on it, you can tell what occurred. So we're going to call this a row 1 and this row 2. Okay, so when I record the new matrix, I'm going to say what has occurred in the row. So I'm going to keep row 1 as it is because I do already have the 1 in the place that I want, right? Our goal is to get, this is our goal, 1, 0, 0, 1, and then who knows what other numbers would be here because that's going to be my solution. And so my 1 is already there, so row 1 will stay as it is. So I'm not going to change row 1, 1, 1, and 8. Okay, so I'll drop writing this line as I work through this. I'll come back to it and put it in once I'm finished. To get what I want in the second one, what I'll do is I'll say I'm going to subtract row 1 minus row 2 and store it over here. So let's do this. 1 minus 1. So 1 minus 1, these two rows subtracted, I get 0. Then whatever I did here, I have to do the same thing. So I continue doing row 1 minus row 2. So 1, subtract negative 1. That's going to be double negative, so that's a 2. And then I have to subtract 8 minus 13, which is negative 5. Any questions? That's equivalent of me just taking this equation right here and starting to subtract. That's basically what happened, except we don't have any x's or y's. So now my column number 1 is done because my goal is achieved. Do you see how I wanted that? I've already achieved that. So then we continue on and work with the next row. So let's write down again. So I'm going to I'm going to take the row 2 that I had before. And this row 2 is going to be the row I just had before, not the row 2 that I had at the original. I want to get the 1 first. Remember, when you're working with the next column, you get the 1 first, then you get the 0. So I want this 2 to become a 1. In order to do that, all I have to do is divide by 2. So let me keep the other row as is. And here I'll have 0. 0 divided by 2 stays 0. 2 divided by 2 is 1. And then a negative 5 divided by 2 is negative 5 over 2. All right, so we are working on the second column, and we got the 1 that we need first. Once you get the 1, then we work on this to get the 0. So next one down. I'm going to keep row 2 as is, so I'm not going to change this one. And I'm going to record what happens with the one up here. So in order for me to get the 0 over here in this position, I have to subtract these 2 rows, but you have to do it in the correct order. If you were to take and say row 2 minus row 1, then watch what would happen. What's 0 subtract 1? Well, that's going to give me the negative 1, and that's no good because now it's no longer positive 1. So we are going to make sure that we do it row 1 minus row 2, because then, looking over here, 1 subtract 0 is still 1, which is what we want. And then we have 1 minus 1, which is 0, which is what we want. And then we want this 8 minus this one to go over here. So let me go on the side, because it's a fraction. 8 minus negative 5 over 2. So that's like a big plus here. And then I need the same denominator, so times 2 here, times 2 here. And so that's 16 plus 5, which is 21 over 2. Once you have arrived here, I'll just draw that separation line one more time. And this is your solutions. Now, I've never talked about how to read this, but please remember what this represents. This is an equation that is converted back to saying it's 1 on the x, 0 on the y, then equals over 2. Well, what is 0y? 0y is not really there, so therefore this is just saying that x is equal to 21 over 2. And then the second row is also an equation that we were just not writing the x's and the y's, we were working with coefficients only. This is saying that 0x plus 1y is equal to negative 5 over 2. So instead of thinking of that, it's just saying y is the negative 5 over 2, and that's why we call these numbers here, once you get the identity here, so this is the identity matrix. And then on this side, we call that part will be our solution. Okay, so I did this simple one, 2 by 2. It gets a little bit more complicated when we have 3 by 3. So let's repeat this process with this example that we've already solved before. But we'll just do it with matrices. Okay, so ready? So first of all, convert it to a matrix by looking at the coefficients and make sure that everything's aligned. So x's are first, y's are second, z's are last, and then all the numbers that are constant are moved over to the other side after the equals. Okay, so we have 1, negative 3, negative 2, and then negative 9, then 2, negative 5, 1, and positive 3, then negative 3, 6, 2, and 8. You can draw a line right there if you wish. If you don't write it, it's okay too. This is what we have so far. So we're going to begin with this column. Our goal is to have the 1 and then the 0 and the 0 there. And you want to work with getting the 1 first and then working at the zeros. Luckily, we already have the 1 first. So, and if that wasn't the case, by the way, I could move things around. So for example, I'm looking at this one over here. Do you see how there is a 1 over here? And I know I want the 1 to be 0, 0, 1 at the bottom. So I could swap. So I'm going to do the following. I'll swap rows 2 and 3, just because then I'll have the one that I want on the bottom here without an extra step. And then this row I'll keep the same, okay? So you would say row 2. So use arrows to indicate that you're swapping them. Row 3. What else can I do in the same step? Probably nothing else. Okay, so 1, negative 3, negative 2, negative 9, negative 3, 6, 2, and 8. So I'm putting 6, 2, 8, the row 3 in the middle now. So it's basically just changing the order a little bit. Just so you're aware that if you see some ones, maybe just move them around to get them in the right position so it's less work later on. Okay, so back to working with row 1, usually, or column 1. I usually just work with one at a time anyway. So I just moved it around just because I saw that there's a one here that maybe we can use later. Although maybe I've done this for no reason, because once I start manipulating these, maybe this one will disappear. I'm just thinking about that. Maybe that was silly of me. I think it was. That one will change to something else as I work through it. And I don't mind that I made that mistake, because I would like you to think about it. Always work with one column at a time. So first column, then work with the second column. Don't look ahead trying to get something in later in the future, because it's actually, I just realized it's not going to help us. because as I try to get this 2 to become a 0, this 1 might not be 1 anymore. It will change. So scrap that. I apologize. Okay, let's do it again. So what I'm going to do is, my goal is to get a 0 right here. So I want a 0. For me to get that 0, what I have to do is work with the row that has the 1 first, because it will be helpful for me to eliminate that 2. So this is what I'm going to do. If you have different colors, it would be helpful to record something in a different color. So I'm going to record just somewhere above here. I'm going to take row 1 and I'm going to multiply it by 2, or even -2, because I prefer adding, not subtracting. And I'll just put it just beside this matrix, but with a different color. So I know my matrix is, what I'm recording here is not part of like my rough work. So row 1 multiplied by -2 would be -2 over here, +6 here, +4 here, and +18 here. So once I've done that, then in order for me to get, let me keep writing with red for my actual matrix. I'll have 1, -3, -2, -9 as before. So I have the one that I wish, so this is good. I'll circle it. So for row 2, though, I want to take my -2 row 1 that I just calculated up top, this blue thing, and I'm going to add it with the current row 2, and I'm going to put it into this middle slot. Okay, so -2 added with this +2 will be my 0. Remember, I wanted that 0, so that's the whole point of me doing that. And then I'll continue doing this addition. The 6 right here that I have with -5 added is 1. Then 4 added with this one is 5. Then 18 added with this 3, that's 21. Check my work, guys. If I mess up, it's going to be really sad, because it's really hard to locate your mistake with just numbers here. Any questions so far? All right, so I want a 0 somewhere else as well. I want a 0 here too. So I might as well do that in the same matrix. I don't have to do it, in a separate matrix. So in order for that to occur, I can do one more rough work on the top here. I could say I'm going to take, or on the bottom, it really doesn't matter where you're going to record this. I want to multiply the one that has the 1 on it. So the row that has the 1 on it, I'll multiply it by 3, because then I can just add it with -3 to get that 0. Applied with row 1, I'll just put it on the side so it's easier for me. So it would be 3 times 1 is 3, 3 times -3 is -9, and 3 times -2 is -6, and 3 times -9 is -27. Okay, so this is just my rough work. It's not part of my matrix, so use a different color so it doesn't look like it's part of your matrix, okay? If you're working with a pencil, you can even erase. After you've done this rough work, you could just erase it. I won't erase, I'll keep it there just so you can come back and look at it, okay? So now that we have this, I'm going to say into this position, I'm going to take row 3 multiplied with row 1, and I'm going to add row 3, right? So this is the 3 times row 1, and this is my row 3. I'm going to add them together. So 3 added with -3 is the 0. So let me change back to red, 0. Then -9 over here added with this 6 here is -3. Then this -6 added with this 2 is -4. What else? -27 added with this 8 is -19, I believe, right? So I have accomplished the first column to become what I want, 1, 0, 0. Next, I'm going to move on to my next column, and I want 1 to be in the middle, which is great. So I'm glad that I actually just erased what I did before, because I actually got the one that I wanted by fluke right away. So that could happen. So we have the 1 now. We just need this one to become a 0 and this one to become a 0. So you repeat the process, except you have to pay attention that whatever you end up doing, it does not mess up our original row, that or column, I should say, that it's still 1, 0, 0. Whatever you end up doing should not mess this up. Okay, so let's continue on. Let's do a different color, again for rough work. So because I want a 0 over here, now that's our goal. So what I can do, I can take row 2 and multiply that by 3. Okay, so I'll just put that somewhere as rough work. So this should be probably in red. Can I change it? Color. Okay, so I'm going to take row 2 and multiply it by 3 and just put it down somewhere as rough work. Okay, so I'll put it over here. So row 2, which is 0 here, multiplied by 3 is still 0. 1 multiplied by 3 is 3. 5 multiplied by 3 is 15. 21 multiplied by 3, let me just double check. 63. Okay, and then I'll do my matrix in my usual color so that I know that I'm not messing anything up. So what I want to do is put my middle row in. I'm not changing that one. It already has the 1, so 0, 1, 5, 21. But in the one that is above it, I'm going to say, I will take my 3 row 2 that I just calculated in green, and I will add it with row 1. Okay, so we're going to take this 0, add with this 1. And notice how it's not going to mess up my original because it's still going to be 1. 0 plus 1 is still 1. That's good. So it's not messing up my first column. Then I'm going to say this 3, add it with this -3. That's my 0. That looks good. Then I'm going to take this 15, add it with this -2. I'm getting 13. And then 63 minus 9, or add 54. Now, luckily, I also have -3 on the bottom. So this green line that I recorded here as rough work will be useful for my last row as well, because I want this to be 0 as well. That one to be 0 as well. And so I'm going to use same computations, 3 of row 2, added with row 3, and I'm going to put it into this position here. So let's do the same thing. Let's do some adding. So I'm adding this bottom red one with this green one. So 0 plus 0 is 0. Notice how I did not mess up my first column. It's still 1, 0, 0. And now let's continue. -3 plus 3 is 0. So notice how my second column is already what I wish it to be. 1 in the middle, 0 above, 0 below. Let's continue adding. -4 with 15 is going to be 11 over here. And then 63 minus 19, 44. Any questions so far? Okay, so now that we have the first column done, the second column done, I'm now working on my third one. And in my third one, my goal is to have 1 over here and then 0 zeros after. So always start creating the 1 first. So I'm going to take row 3 and divide it by 11. So it'll be 0, 0, 1, and 4. And the other ones, just copy them. We'll deal with them after. 13, 54. Any questions so far? So now that we have the 1, then I'll again do the rough work. So use different colors or somehow separate your work. So we want 0 over here. Well, so I think I should do a calculation of -5 multiplied with row 3 as rough work, and also -13 multiplied with row 3 as rough work, because then we can just do some additions again. Okay, ready? So over here, I'll just put down a row that's taking this row 3 and multiplying it by -5. So I'll have 0, 0, -5, -20. And also I'll do the -13 because I'll eventually need it for this one to eliminate that. So I'll put in a 0, -13. And what's 4 times 13? 52 with a negative. Okay, so this is rough work. This is not my matrix, so use a different color so that you don't get mixed up. And then I'm going to have my row 3 will stay the same. So 0, 0, 1, and a 4. And so into this position here, I'm going to take -5 row 3, add it with row 2. Okay, so let me highlight so you can see what I'm trying to do. I'm doing this one with that one added together. Okay, so your attention is on those yellows. Okay, ready? So 0 plus 0 is 0. 1 plus 0 is still 1. 5 plus -5 is 0. And then 21 plus -20 is a 1. Okay, so I'll remove that highlighter. So now I need to also eliminate the 13 over here to be a 0. So that would be -13 row 3 that I've calculated as rough work in green. And I'll add it with row 1. So let me highlight that so it's easier to tell what I'm doing. It's this one added with that one. Okay. So 1 plus 0 is 1. 0 plus 0 is 0. 13 plus -13 is 0. And 54 plus -52 is like subtraction. So it would be just a 2. And look at that. We've arrived at our identity here. So this is the identity matrix. And that means this must be the solution, which is x equals 2, y equals 1, z equals 4. To try this one right here. Your goal is to get that one to be 1, 0, 0, 1 with some numbers over here. Okay, so join Pear Deck. And let me give you a slide on Pear Deck once you're in so you can get right to it. Okay, this is your matrix to start with. Your goal is to get 1 first, and then you're going to get, so this will be with fractions, it's okay. So make sure you copy it correctly, it's 12. So I can guide you. You're going to take row 1 divided by 12 and store it here first. And if it's fractions, just reduce fractions as you move on. It's okay. Okay, so you should have gotten a 1 over here. Check your work. So 21 divided by 12 as a fraction that is as reduced as possible. It's going to be -7 over 4, right? And then 9 divided by 12 as a fraction is 3/4. Okay, your next step. Your next step is to get a 0 here. So what you might want to do, maybe with a different color, I think Pear Deck allows you to change colors. You might want to do a calculation somewhere of taking the row 1 the new row 1 that we have and multiplying it by -8 or by +8. It all depends whether you prefer adding or subtracting to eliminate. Okay. Some of you may have lost a negative. Nadine, you have a negative on your 7/4. I think you should be negative there. All right, so my rough work for just the green color that I'm going right now is going to just multiply by -8 my row 1 that I had there. That's the reason we're getting the 1 there. That's one of the reasons we're getting the 1 there, so that we can multiply it much easier. So I should have -8 here. And then my fraction, 7/4 multiplied by 8. Also try to reduce it as you go. And actually, it's not going to be a fraction anymore because 4 divides into 8, so it should be positive 14. And then 3/4 times 8 as well. There's going to be no fractions anymore either. It's going to be -6. So this is just my rough work. It's not part of my matrix. And then my matrix itself will have row 1 as it was, so don't change row 1. But the bottom one will be -8 row 1 added with row 2. Okay, let's see how you guys are doing. Okay, so you should notice that here you'll have 0 and a 0, and then -3. Okay, so pause what you're doing, stop, because here this is going to be impossible to continue on using the matrix, because remember how our goal is to have a 1 here, needed 1 here for identity matrix. So stop what you're doing, just watch me from here on end. So because we're getting something like that, it is still a solution that we can interpret. So let's take a look at what does this mean. Let me just change the color here. So remember what this represents. This represents an equation that says 0 of x's plus 0's of y is equal to -3, which is saying that 0 is equal to -3. What did we say yesterday is the conclusion when we get this false statement? What does that mean about our original system?
No solution.
No solution. So this is a contradiction. There is no solution. And that can happen, right? So this, these two lines right here, they end up being, if you were to interpret it graphically, there's going to be 2 lines that are parallel that never meet. Oops. Now this is in 2 dimensions, there are 2 lines. In 3 dimensions, this would be 2 planes. So in 2D, it's 2 lines. In 3D, if you're thinking about it as if there is a plus 0 z there, so it would be 12x minus 21y plus 0z equals to 9. And then the normal vector would be the 12, comma, -21, comma, 0. So if that was your interpretation, then you'd basically have 2 planes that also never meet. So 2 lines not meet, or in 3D, 2 planes not meet at all. Okay, so that could happen. So let's talk about one more. This one also we have done in yesterday. It was where we had a line of intersection. So there's infinitely many solutions. So this is 3 by 3. So I'm going to give you a new slide and try to write small, at least begin this. I know you won't have space to do all of this, but I'd like you to convert this to a matrix first. What is the actual matrix that it's going to be represented? And start getting the 1, 0, 0 portion, just so you can have a chance to practice it on your own. Okay, so if you have converted it to a matrix first, this is your way to verify it. Let me tell you what the answer is. It would be 1, 1, 2, -2, 3, -1, 14, then a 6, then 1, 2, then 0, -5. So you already have a 1 in the first position, so that's good news. We want a 0 and this bottom one to become a 0. So if you're not sure what to do, let me tell you the steps. So for the middle one, you're going to multiply row 1 by -3 and add with this row in the middle. And for the bottom one, you could do row 1 subtract row 3. Go ahead and do that. If writing on Pear Deck is too annoying for you, you can do the work on the page and just record, you know, the next matrix that you get on Pear Deck. So I like to see my rough work in a different color. So I'll start doing that. It will allow me to change my color. Here we go. So -3 multiplied with row 1, I'll put it up top. So that would be -3, -3, -6, and +6. Okay, and so if I were to highlight for myself so I know what I'm doing this one and that one added together. Okay, so if you want to glance at mine to see if you have your middle row correct. Okay, so if you're okay with that, then I'll change what I'm highlighting here. Now I'm going to row 1 and 3. And please remember that this time I'm actually doing subtraction, not addition, to get my bottom row. So 1 minus 1 is 0, 1 minus 2. Pay attention to the order. is going to be -1. Then 2 minus 0 is still 2 here. -2, subtract -5, that's double negative, so I'm getting a 3. So check your last row. I have 0, -1, 2, then 3. Isn't 6 plus 6, 12? Did I mess up?
I was going to say, how did you get the 0 as the result on the third row?
On the 0 over here?
Yeah, like under the -2. Oh, sorry, the second row, under the -2.
Oh, this 0 here? I don't know. Maybe I messed up. It should be 6 plus 6, which is 12. Oh. So who's that?
Nadine.
Nadine and Antonia also messaged me. So both of you, thank you. Nadine. Any other mistakes I've made? Or is this okay? All right, so now that we have that first column accomplished, your next goal is to get the 1 in the middle over here. Right? So you could take row 2 and divide it by -4. So it'll be 0, +1, -2, -3. And copy row 1 as it was, and row 3 as it was. Okay, you probably now ran out of space on your pear deck, so stop what you're doing and just volunteer to speak up. What should I do next?
Add R1 to R3.
Okay. R1 and R3 added, and that will be stored into the first one. Okay, so you'll have, I'll highlight it. I'm highlighting these two, so I'm adding this one and that one, and I'm putting it in the first position. So 1 plus 0 is still 1. Oops, can't write with the marker. 1 plus 0 is still 1. 1 plus -1 is 0. 2 plus 2 is 4. -1 plus 3 is, or -2 plus 3 is 1. What else should I do in this row? So I'll keep the middle one as is because I have the 1. What else should I do? So remember, we want this one to be 0 and that one to be 0. So let's think about this bottom one. How do I get a 0 over here? I think we can do adding again, no? Row 2 and row 3. Oops. We can do addition. So let me highlight the ones that we're going to look at. I'm going to take these two and start adding. Okay, so 0 plus 0 is 0. -1 plus 1 is 0. And then 0 and then 0. Oh, it's impossible now to get an identity matrix again. Impossible to get 1 here. So we need to talk about what does that mean. This row imply? This row is actually saying 0 x's plus 0 y's plus 0 z's is equal to 0. And which is 0 equal to 0, which is a true statement, which means infinitely many solutions. Okay, so just like I mentioned here that this was actually where we had a line of intersection. So how do we go back working from this? You will then say, okay, because we got this whole equation becoming 0, so it's basically like one equation is redundant now, it disappears, then we need to use one parameter. So since one equation became redundant, need one parameter. So we're going to take the parameter So we're going to take this right here and interpret it. This means that there is 1y minus 2z's is equal to -3. So let z be the k, right? Like we did yesterday, I'm just repeating it. Then y would be equivalent to 2z added on the other side plus subtract 3. And just put that k in terms of instead of z, so -3. So I'll circle this one. We have that parametric form, that parametric form. And then you go back to where we had the 1 as well. So let me draw an arrow this way. So we have 1 with an x, 0y plus 4z equals 1. And so getting x by itself will be -4 on the z plus 1. But z is just the k. So x is equivalent to -4k plus 1. I'll circle that. So that's my parametric form. So therefore, line of intersection. We've done this before. I'll just put them side by side. X would be -4k plus 1. Y is 2k minus 3. And this is just the k, or vector form. Let me give you a new slide on Pear Deck. Can you give me the vector form from this parametric form? Okay, how are we doing? Okay, some of you are done, some of you are still working, so a couple of seconds more and then I'll take it up. Okay, so let's take it up. So there's going to be the known point, or I keep calling it a point. It's technically point in quotations. It's a vector that's pointing at the point, so it's like a position vector. And then we have the direction vector of the line. And so the x parametric version, we have 1 without the k and -4 on the k. So 1 goes here and -4 goes here. Then -3 and 2. And then we have 0 here and 1 over here. Okay, so if you got that, good job. All right, so in terms of matrices, doing it by hand, you'll practice in your homework to do it by hand, a few questions, but also I'd like you to practice how to use technology. So let's switch over to using technology now. It seems like it's going to work. And let me just go like this split screen so I can show you the steps you're going to be doing, because I don't remember the steps myself. I don't really use matrices very often. All right, so it says here to start the matrix, we're going to use a square bracket. So make sure that when you press the blue button here, you'll see that on the bottom it actually writes down second. So if you press it again, that second disappears. So you'll know whether you've pressed it or not by seeing something on the bottom of that calculator screen. Okay, so anything that's in blue above the buttons, to access everything that's in blue, you will be pressing that second function. If you want to access anything that's in this yellowish color, then you would be pressing this button right here. Okay, and then anything that's in white is the alpha button here, because there's an alphabet A, B, C, D on there. Okay, so we're going to access the square bracket. So we're going to do second And then the square bracket is above the comma. So above the 9, there's a comma, press that. So on the screen, you'll see that there is a square bracket that got typed in. Okay, let's continue. What else do we need to know? Where did that come from? I think it's the one of the questions I wanted us to practice later. So other things we need to know is to separate rows, we're going to separate them with semicolon. To end the matrix, we again use the square bracket, but the one that will close it. And then we can also store the matrix into a specific letter so that we can actually work with it. Okay, so these are the main things to do. So hang on a second, let me think. Convert it to row echelon form. I'll talk about that later. Okay, so let's do the one that we were just working with. So let me just copy these numbers because I won't remember them. Give me a moment. Okay, it sticks it over there. That's fine. Okay, so follow along. So the first row is 1, 1, 2, and then -2, right? So you type in 1. Hang on a second. Matrix with a square bracket. I thought I didn't tell you. I think you have to use a comma between each one. Okay, let me just verify. So I think you have to put 1, comma, then the next one is 1 again, comma. I didn't write that down in my little notes here. Then the next one is 2, comma, then -2. So -2 and then the subtraction sign, you have to actually press the one that's below the 3 for the negative. Don't use the subtraction because calculator doesn't know that it's actually equivalent in, theoretically. So you have to put negative and then 2. And then we want to say that we're on to now the next row. For the next row, we want to do a semicolon. So second function 9, above that is semicolon. So second function 9 now. And now proceed with the next parts, which is 3, -1, 14, and 6. So 3, comma, -1. I hope this works. Maybe just watch me for now. What if I mess up? I think it's commas in between. I haven't done this in a while, so just watch me for a moment, okay? Comma, 6. And then semicolon again. And then what do we have? 1, 2, 0. So 1, 2, 0, because there's no Z. And then -5. And then I'm going to close off my matrix. Like that. If I press enter, I'm hoping it's going to display as a matrix on the top. It does. Okay, so commas were correct to use. Okay, so it actually displays it as a matrix. And if you ever want to actually go back so you don't have to retype this, if you scroll up like this, it will actually select that matrix so that you can press enter and use that matrix without retyping it. So everything is stored in history. So that as you type more, it just goes, kind of gives like a scrolling feature. So you can always go up to what you had before. Okay, so now that we have this matrix, we want to do some operations on it. So that's why I have on the side. So just watch me for now, and then you'll practice. What we want to do is maybe store this matrix into a letter so that if you don't want to go scroll up and down to select it every time, you can actually store it somewhere and then just say, I'm going to do operations on this variable. And so this variable is going to hold the matrix. So it says here, we can use the store button. So for us, the store button is, where is it? I don't see it.
It's above the on button, I think.
Above the on button.
Bottom left.
Oh, right there, right there. Yes, yes, thank you. I was like, where is it? Okay, so we're going to be using that one. And so the way to do that, I believe if I just press this button as I have even if I was at the bottom where I just entered this and I pressed enter, if I press store, it's going to take my answer, meaning what I just had entered as an answer, is going to put that into, and we can put it into any letter. So let's use alpha. So if you use alpha and then just choose a letter. So let's say store it into A. So do you see how it says store into A? And then press enter. And it just, it did store there. So then you're going to ask the calculator to convert this matrix into the identity version and then the solution so that it's, ones with zeros and so on. So in order to do that, let's take a look, I forget. Second function 5. Okay, so if you click on second function, and then 5 for math, so that we're accessing math here. And what it does, it pops up a window. In this window, you could actually use your arrows to scroll up and down, or you can actually hit a specific number. So what we're looking for is the 4. So you either hit 4 or scroll down using arrows to the matrix itself. Now, if you hit 4, you'd have the actual next thing. Do you see how there's little arrows here on the side? That means there's another menu that will pop up. Okay, so if you were using arrows, then you have to click on the arrow to the right to open up that new menu that's inside of it. So here we can, there's actually two things. There's row echelon form and then there's row reduced echelon form. Let me do both of them so you can see the difference. Okay, so I'm going to select the 3. Okay, and now notice how it has this command. It's going to do echelon form, and it's waiting for what? And here you can either retype the whole matrix if you wanted to, but that's too much work. So I'm going to say I want to actually use A. So to call up my A that I stored it, you press alpha again. And you know that alpha key is selected because there's a little A that shows up on the bottom there. And then press the equals sign here so that it actually grabs that A. And then you can close that bracket here and then press enter. All right, so what it does is a row echelon form is it's basically creating zeros. So I did not write that down yet. Let me do it in my note here. Row echelon form versus reduced echelon form. Basically it does the following. It's actually hard to see on ours because we get 0, 0 on the bottom there. So this would be 1, 1, 1. Oops. 0, 0, 0. And then there's going to be numbers here. Like so. Whereas this one is a full identity matrix that has zeros not only on the bottom, but also on the top. And that's the one we've been practicing. Okay, so I'm going to do the same thing again. I'll do it again. So I'll go to second function for math. I'll go to matrix. And this time I'll select RREF, so the 4. And then I'll say again, do it on the matrix A. So alpha A, close bracket, enter. Okay, so it doesn't look much different just because we have a row of zeros. We have a redundant matrix here. And so it gives you this already reduced. And then from here, you would do, because we have a redundant row here, you would have to still do some mathematical work that I've done with you about line of intersections, right? So we just did it over here. We said if we have something that is true and variables are starting to disappear on you, you know that there's infinitely many solutions and you need to introduce a parameter. So that part the calculator won't do for you. Converting to parametric form and vector form, you have to do on your own.